This one. I'm going to keep looking at that one probably, but I've got the here because when I'm looking at the screen, you can see my hideous face easier. Plus, I've got the cool glare on here. Anyway, to the point. Hello, ladies and gentlemen and other. Today, I wanted to cover something a little bit more important. Something which a lot of people have been neglecting, especially during this massive chip crisis, is the inner workings of the equipment that they're working with. Because people are having to take shortcuts, which unfortunately is a necessity right now. We're having to find alternatives to the equipment that we commonly use, and people are running into bottlenecks. So it's important to understand how your hardware operates so that you can set it up appropriately to get the most efficient use of it. Yes. So that's where block diagrams come in handy. So if you go to your manufacturer's website, I know Microtik, because I'm a bit of a Microtik whore, has got all sorts of wonderful stuff under the supports and downloads, including your block diagram right here. There's most manufacturers, you can find these doing a quick Google search. Microtik fortunately don't give a crap if people look up their skirts. So what we're going to do here is we're going to look up our Microtik router skirts. So when you look on the page for these guys, typically you guys are going to come here and you're going to see all the specs, blah blah blah. CCR 1009, test results, blah blah blah. But how many of you guys actually click on the support and downloads and actually look at the block diagrams or the SFP compatibility list? Let's take a look what those guys have first. So here's the SFP compatibility list, and this will actually show you what Microtik modules are compatible with what devices here. And this is important because it turns out that the CCR 2004 is not compatible with the card itself, is not really compatible with anything Microtik. It's probably going to be Intel, I'm assuming, or Cisco. 4011 here, what's it not compatible with? SFP plus DAC. Well, we all know that. The 4011 can't run the DAC. What else can't it run? Oh yeah, it can't run anything bigger than 10 gig. But now let's start taking a look at some block diagrams, okay? So one that's really, I've got on hand right now is my little crappy 2011 here that's got a bad, somebody sent this to me as a donation. It's got a busted off LCD screen, and it's basically just got the circuit board and that. So it's sitting on my bench, but I digress. Let's take a look at something here. This is why it's important to take a look at these things. See here, it'll list off the ports and what they're doing and what they're capable of. Ports 6 through 10 are the second grouping on here, because you've got 1 through 5, 6 through 10, and then an SFP, okay? There's your visual aid, see? Visual aid. All right, so now, that being said, you'll notice this will show you how everything's connected back to the CPU, and that's very, very important if you want to be able to get the most efficient operation out of these. With the RJ45s here, 6 through 10 are only 100 megabit per second. They've got their own switch that has a gigabit trunk that goes back to the CPU. Now, if we take a look at the, here we go, the gigabit switch here, it's 1 through 5 are all part of this same 1 gig connection back to the CPU. But here's something else on the 2011. The 2011's SFP port shares that same switch, which means that basically all the gigabit ports on this little 2011 here, they all go straight through a 1 gig switch. So the SFP and ports 1 through 5 are all bound together, which means you can't, it's only got 2 switch interfaces, that's it. So now let's move on to something a little bit more robust. Let's take a look at the Hex S, which is also one of my favorite routers. Look at the difference in the CPUs here. Ugh. The Hex S is actually kind of a clever animal. Look at this. The SFP has a direct connection back to the CPU, but XOR. Okay? So, that SFP shares its gigabit port access, its gigabit interface access to the CPU with 1, 3, and 5. See how this diagram is? You've got Ethernet ports 1 through 5 here, right? This is representing the grouping. Okay, the little switch chip. All right, so SFP uses the same gigabit interface back to the CPU as 1, 3, and 5. 2 and 4, on the other hand, have their own 1 gig lane back to the CPU. So what this means is that if you're setting this up on your site, you have to be mindful, because let's assume that you've got a midpoint site where you've got a backhaul coming in, a backhaul going out, and 4 sectors on it, okay? Well, you want to make sure that the sectors are on a different interface as the inbound, as your uplink to the next tower, like the first tower, I guess you should say. The ADHD mind, and I'm not scripting. Okay, let's use this. All right, so this is going to be your tower right here. Here's tower 1. Here's tower 2. Yay, this is the equivalent of an IT drawing with crayons. Okay, and now you've got your backhaul. So this is your backhaul. Right? And then let's call these guys your sectors. There we go, there's your sectors. And then let's say that there's another backhaul out. Okay? There's another backhaul out. So now we're going to pretend that this is your router at this site. And let's make it red. Red for router. Haha. Okay, so now we want to make sure that the connection coming in from here goes into one switch group. Okay? So I would say in this case here, I would use switch group 1. So I would then devote this 1 gig interface right here to your inbound traffic / outbound traffic. It depends on how you look at it. Basically, we want the first gigabit interface to go to the front of the network where the fiber connection is, or whatever you guys are using. And then we want to reserve ports 2 and 4 here to feed all the downstream traffic, which would be the next tower site, or would be the access points or the access points on the tower itself, okay? So let's go back to the drawing now. So this would be our inbound from here, right? And then let's draw another line. Yay. We'll go like this. Okay, I'm going to draw a bunch of lines here. These are going to represent your connection back, okay? And then that would be to here. Your blue is your downstream, meaning that it's heading out into the network away from the fiber. The red is going to be the upstream, meaning towards the fiber connection, okay? So what we're trying to do here is we're trying to make sure that all this traffic is not occurring on one of these gigabit lanes, because if all that happens on the 1 gigabit lane here, you're basically sort of having it, especially depending on the detected interfaces with it, because, I mean, technically, it's like, depending on the chipset, it could be a solid 2.25 gigabits per second on that lane, which means that you get full 1 gigabit in both directions, full duplex. There's a lot of tech out there that it's the 1 gig interface, but it's not 1 gig AG. It's 1 gig TX. So you have to be careful about that, because then you're having it. So if you've got a lot of traffic happening on that 1 gig lane, you're actually only going to max out TCP, be able to do about, what, 500, 550 megabits per second. Whereas if it's a proper lane and it's 2.25, then you're going to be able to do full duplex 1 gig in either direction. But you're still going to cause a little bit of, you're going to overwhelm the tech a little bit, okay? So the idea here is, again, to reiterate, because I'm trying to pound this home, I'm trying to drive it home, right? Is that you want to use one of the 1 gig lanes to the CPU, specifically for your forward traffic. Okay, so you want anything that's going to the front of the network, to your fiber connection, to use one of these 1 gig lanes. And then anything that's going away from the fiber is going to use the second 1 gig lane. So as an example in this configuration, we've got the SFP, we've got ETH1, 3, and 5. So let's say that you don't have anything that's SFP capable, okay? So what we would do in this case here is, let's say we're using an atonic switch. I would use ports 1 and 2. You see, because 1 is on the first 1 gig lane, and 2 is on the second 1 gig lane. Now what I would do is I would tag all of my uplinks, or my uplink traffic. So I would have my backhaul feeding this site tagged to go through Ethernet 1 here on this little router. But then I would take Ethernet 2 here, and I would have all the access points at this site tagged on Ethernet 2 to bring down through the second 1 gig lane. And also, any towers that are downstream of this particular site, I would also tag their VLAN, their point-to-point VLAN, on the port that's going here at the Ethernet 2 as well. And that'll ensure that the traffic is actually going in 1 gig interface and going out the other 1 gig interface. Now, don't forget, Ethernet ports have 2 gigabit per second aggregated lane to CPU until SFP module is inserted. That's a cool little note on there, by the way. So that also, you need to consider that the CPU on this thing is also limited. So, I mean, like this guy here, these little guys will max at about 550 TCP when you're really hammering them, okay? So these are all things you need to consider, but still, regardless of that, I mean, some of you are going to say contrary. Oh, well, if the CPU is only capable of about 550, well, then it doesn't matter what ports I use. It's just like, it's a cleaner stream. It makes things a little bit easier on the chipsets. Don't run things maxed out. Always try to keep them running lighter than they are so that you don't hit your mean time failure. Okay, let's take a look at another one now. So this is the hex S. Remember that. The SFP shares a 1 gig lane with ports 1, 3, and 5. You might as well call that a combo in a way, right? Except the tricky part here, here's the cool part. The SFP is actually after the switch chip. So the SFP actually shares the 1 gig lane to the CPU after the switch chip. So these guys here still go through that. So that's basically what's happening here. So what I'm going to assume in the functionality here, Ethernet ports have 2 gigs ag. So if this one is not being used, then all these ports here will share both these lanes, sort of like a bonding back to the CPU. But as soon as you activate the SFP, this connection here is taken down, and then it's all going to run through this way. XOR gate. Let's look that up. XOR gate. XOR gate is a digital logic gate that gives you a true output when the number of true inputs is odd. An XOR gate implements an exclusive OR from mathematical logic that is a true output result. If one and only one of the inputs to the gate is true, if both inputs are false or both are true, a false output results. Cool. All right, so there you go. There's your basic logic lesson right now. Go look things up. You've got Google. All right, so let's take a look at a hex PoE now. What do we have here? RB960PGS hex PoE. So what's interesting here is that the SFP is one of the interfaces to the CPU, and then ports 1 through 5 are the other interfaces to the CPU. So you still have 2 1 gig lanes back to the CPU using the SFP. So in this case here, what I would do is I would actually connect port 1 to one of the PoE out ports on the switch, and then connect the SFP to the SFP on the switch. What that would allow you to do is not only power this little router from the switch through Ethernet 1, but then you can put all of your downstream traffic on the SFP. So you see we're dividing it up, so the upstream and downstream traffic are on 2 different 1 gig lanes to the CPU. Let's take a look at the 4011 now. What's this one look like? This thing has a beefy, sexy, chonky core. Look at this. Look at the capabilities on this one. Two 2.5 gigabit per second lanes here. So let's just say that you don't have switch connected to this and you're just going to use a midspan injector. You can put your midspan injector on all 10 of these ports. Now, I would try to keep that on the first one. Or, alternatively, let's say that you have an SFP RJ45. Here we go, 4011. Okay, so we can actually use an RJ45 adapter on here. We've just confirmed it. No problem on here, which is ironic because you can't use a DAC. Okay, so let's go back over here. So here's a theoretical for you. We could put an RJ45 SFP into SFP1, connect our backhaul that feeds us from the fiber site into that port, and then you've got 10 ports here that you can feed your sectors on the tower with, or you can feed the downstream sites with. So that's just a midspan representation, where you would actually get a DC midspan injector, which is basically just a PoE injector, but it's a grouping of them. And you plug each one of those into each of the ports on here. So yet another configuration. Let's take a look at a cloud core now. Ooh, isn't that neat? This is also another great example of the XOR gate. This has a combo port on it that's either SFP or Ethernet. So that gives you the ability to have optical isolation if you're connecting to your upstream's NID. Because in a situation like this, I'm going to explain this for 1 second. Let's say that you're at a site and your upstream refuses to give you a DC compatible NID. So they don't give you a Sienna or a Cisco or something that might actually have a DC connector on it. They give you something that's got an AC power cord on it. So now you need to run that on a UPS. Everything else on your site is running on battery backup. You've got a proper DC plant. Because you're using 2 different power sources for 2 different sets of core equipment that are running at the same site, you can get a power differential between the devices that can blow your shit up. So in situations like that, it's best to optically isolate those pieces of equipment. So you can then use Ethernet 1 or the SFP, which are, you can't use them at the same time. Don't use them at the same time. You can either use copper to connect to your NID, or you can use fiber. So anyway, that being the cloud core, it's safe to assume every single one of your ports is direct to CPU unless it's labeled as a combo. Anytime you see something's a combo, it's going to be like combo 1, so SFP or ETH usually. Like we saw actually back here. See, this is technically a combo port here, but it's a combo before the switch. So if this port's not being used, these 2 1 gig lanes are bound together to allow for 2 gig traffic to give all this stuff connectivity. As soon as you connect this, it cuts off one of the 1 gig lanes and steals it, right? All right, so with that being said, you can do whatever the hell you want with this thing, but with any router, I try to keep it down to 2 interfaces connected. You have an in interface and an out interface, upstream, downstream. This is why, if we're doing a very busy site, you want to do your router on a stick with something that's 10 gig capable. because for the most part, most WISPs are small operators. You can use a single port on the router to power the router, or use the DC-in connector if you want to monitor site voltage, and then have your SFP Plus go up to your switch, so you've got a 10 gig AG connection between the switch and the router, which guarantees you 5 gigs in either direction, which as a small operator, you're probably not going to see that on your specific sites, and if you are, that site's probably far more important and probably has bigger equipment on it, okay? I know that I haven't been doing much tutorials on how to do things lately, but honestly, I got kind of bored of doing tutorials. Plus, I'm currently working on re-educating myself with Cisco and other brands as well, so I'm just kind of burned out on the MikroTik tutorials, and I will be doing more at some point, but I want to get really, really good with the Router OS 7 stuff before I start doing tutorials. Of course, if you guys want to see great network tutorials on how to program your MikroTiks and whatnot, you can always check out the Network Berg. He's got an amazing channel where he does a lot of in-depth tutorials, and he's already on Router OS 7. And if you want some Ubiquiti stuff, Willie Howe's channel actually has a lot of good Ubiquiti stuff. But that's not to say I'm not going to do more tutorials. So anyway, thanks guys. I hope you enjoyed that. Go kick ass, okay?